Hello students, I am Ashish De. I am taking one of your subject, that is digital communication. In my earlier video, I have solved some problems on PSK that are in BPSK, QPSK, M-array, PSK technique. Okay. Now in this video, I want to draw some waveforms on different line coding formats. Okay, in my earlier videos also I have drawn some waveforms in different line coding formats. Today there is a practice session of those things. Okay, so suppose I want to take a bit stream or bit sequence like this. This is the bit sequence 1 0 1 1 1 0 1 0 1 and 1. So this is the bit sequence is given, and each bit is divided by cells. Okay, so here are the cells of the bits. Okay, now at first we have to draw some dotted lines for each cells. Okay, lines are taken in the half portion of the bit and the full portion of the bit. Okay, for each bit dotted line is taken for half portion and full portion of the bit. Okay, so dotted lines are given. Okay, now suppose we have to draw unipolar return to 0 and non-return to 0 type waveform. Okay, so first unipolar return to 0. In unipolar return to 0 type format, this is the time axis that is indicated by T, and this is amplitude portion. Okay, in unipolar return to 0 type, in the first half of the bit there is a amplitude or positive amplitude of A. In the preceding half or next half of the bit there is no amplitude. Again, when the bit is 0 there will be no amplitude. Okay, again when there is a bit of 1, the same thing is repeated. In the first half there will be a positive amplitude of A. So for this also this thing, and here is also 1, so the waveform will be this. Okay, now this is 0, so there will be no waveform. Now here is 1, So the waveform will be this, and for this the waveform will be this. Again for this the waveform will be this person. Okay. So this is unipolar return to zero type or RZ. Okay. Now unipolar non-return to zero. For unipolar non-return to zero type, the waveform will be for the entire portion of the bit. Okay. Now when it is 1, the amplitude will be A for the entire portion of the bit. Okay, for two half of the bit. And when it is 0, the waveform will be, and there will be no waveform. Okay, again when it is 1, then there will be a waveform. Okay, now again there is a 3 successive ones, so it will not ended to 0, it will continues up to this portion, this. So this will be the waveform. Okay, now here is another one, so the waveform will be this. Okay, now there are two successive ones are here, so here will be the waveform. Okay, and it will goes to 0 here. Okay, so this is unipolar non-return to 0 type waveform. Now bipolar return to 0. In the bipolar return to 0 type waveform, the total amplitude is divided by a by 2 plus a by 2 and minus a by 2. Okay, so for when the bit is 1, then it will have the amplitude of plus a by 2. Okay, and in the next half of the bit it goes to 0. When the bit is 0, that means it has negative amplitude, so there will be a negative amplitude here in the first half of the bit and it goes to 0. Okay, this is minus a by 2, this amplitude is minus a by 2, right? Now again there is 1, so here will be a positive amplitude in the first half and it goes to 0. Again positive amplitude and it goes to 0, positive amplitude and it goes to 0. Okay, now this is 0, so there will be a negative amplitude and it goes to 0. Again it is 1, so there will be a positive amplitude and this is 0, so here will be a negative amplitude. Again there are 2 ones, so here is positive amplitude. Again here will be the positive amplitude, okay, of a by 2. So this is bipolar return to 0 type waveform, bipolar return to 0 type waveform. Okay, now there is another waveform, bipolar non return to 0. Time axis t. Okay, in the bipolar non return to 0 type, there will be, so it does not return to 0 in the entire portion of the bit. Okay, here will be a by 2, amplitude will be a by 2, right, for the entire portion of the bit, and when it is 0 it will be minus a by 2. Okay, again now there are 3 ones, so 1 2 up to this portion, up to this portion. Okay, so here will be a by 2 and this amplitude is minus a by 2. Okay, now there will be a negative amplitude, negative a by 2, minus a by 2, because this is 0. Okay, 0 up to here, up to this portion. Okay, now this is 1, so this will not be. Now this is 1, so positive amplitude, again 0, so negative amplitude, again there are two ones, so there will be a positive amplitude. Okay, and it goes to 0. So this is bipolar. This is the waveform of bipolar non-return to 0 or energed type. Okay. Now split phase Manchester. In split phase Manchester, or in simple Manchester formatting, in split phase Manchester type of encoding, there will be a positive a by 2 in the first half of the bit when the bit is 1, so this is positive a by 2, and in the next half it will goes up to negative a by 2, so this amplitude is minus a by 2. Okay, and when it is 0, it will starts from negative to positive a by 2, so in the next bit is 0, so it will continues up to here and it will goes to the positive. Now here is 1, so for 1 at first positive a by 2, and there will be a negative a by 2, again it is 1, so positive a by 2 to negative a by 2, again there is another one, so this. Okay, so this is the final one. Now 0, so negative a by 2, and this is positive a by 2. For 0, it starts from negative to positive. Okay, and it will continues up to here because there is another one here, and it goes up to negative a by 2. Okay, now 0, so this is negative a by 2 to positive a by 2, again 1, so this is positive a by 2 to negative a by 2, again there is another one, so positive a by 2 to negative a by 2. So this is the waveform of Manchester or simple split phase Manchester. For so now the waveform is polar quaternary. As we know, in polar quaternary format, when the we have to take two combination of bits. Now when two bits are 0 0, then the amplitude will be minus 3 a by 2, when 0 1 minus a by 2, when 1 0 a by 2, and when the bits are 1 1, so 3 a by 2. Now the starting bit is 1 0, so it will be a by 2, so here will be a by 2. Now there is 1 1, bit is 1 1, so 3 a by 2, the amplitude will be 3 a by 2 here. This will continues up to here because 1 0. Now the bit is 1 1, so it will continue up to here, this portion. Okay, 3 a by 2, this is 3 a by 2, and this is a by 2, right? Now the bits are 1 0, so it will be a by 2, and it will continues up to this portion, this. Okay, now again a by 2, so it will continue up to here, a 0, so up to here. Okay, now there is another 1 1. Okay, so it will be 3 a by 2. So this is the waveform for polar quaternary energized format. So this is the waveform of polar quaternary energet format of two discrete amplitude A by 2 and 3A by 2.